Hey kiddos, today we're going to talk about two other types of triangle congruency theorems, which are angle side angle and angle angle side. These are going to be the last two, so these are the only ones that exist, which are HL, hypotenuse leg, SSS, side side side, SAS, side angle side, and then we have these last two, angle side angle and angle angle side. Those are the only five triangle congruency ones that actually exist. Okay. So angle side angle is when if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So we've already talked about this term before, included, okay? We've talked about an included angle. So an included side is essentially the exact same thing. The only difference is it's a side instead of an angle, okay? So basically this side, if you notice in the letters ASA, the side has to be in between the two angles in order for this to work. So as you can see here in this picture that we have triangle ABC and triangle XYZ, and they're showing us some congruency items. So we're going to go ahead and write these down and match them up. So we have that angle A is going to be congruent to angle X. We have the included side of segment AB would be congruent to the included side XY. And then we also see that angle B has two markings just as angle Y does. So because of all this, because we have an angle, okay, we have an angle, we have a side in between another angle, then we can justify that this triangle ABC is in fact congruent to triangle XYZ because of angle side angle. Angle angle side now. So AAS, angle angle side. If two angles and a non-included side of one triangle are congruent to two angles and the one non-included side of another triangle, then the triangles are congruent. All right, so we could also technically have a situation where we have two angles and then we have a side that's not included, meaning that it is not in between those two angles that are marked as congruent, okay? So this rule still does actually apply in creating congruent triangles. So in our two pictures here, I can see that angle A is congruent to angle X. I can see that angle C is congruent to angle Z. And we can see that the non-included side that they both have in common, and they're both the same, are line segment AB and line segment XY. So because they have the two angles and a non-included side that are marked as congruent, triangle ABC is going to be congruent to triangle XYZ. All right, so let's look at two examples here. Okay, so example one, notice I see that we already have a few markings here, and what we have to do is try and see if we can find any others, okay? Because typically for all of these, you have to have three. So hopefully, if you have to, please remember that you can always redraw calendars, redraw triangles to look like the other ones if it makes it easier for you to identify what is in fact congruent, okay? So all I did was I redrew this bottom triangle DGF into the form like this so that it looks like triangle DEF, okay? And it helps me really clearly see which ones match up and if they actually do. Now, one marking that I've forgotten to make is that we can easily see that in both triangles have or share the line DF. So notice that is the reflexive property being at work here. So what we would then be able to establish is we have apparently angle D congruent to angle F. We have that angle F is congruent to angle D. And we also have side DF is congruent to side FD. All right, so we have an angle, and notice key here is where is that side located? The side is located in between the two angles, so therefore this would be angle, side, angle. Number 2. All right, we see here that we have angle A and angle E being congruent, and we also have this side here being congruent. I'm going to imagine that this is supposed to be the letter C there, okay? So we have BC is congruent to BD here, and we're looking to see if we can find one more piece of information. Hopefully you guys do recognize or remember vertical angles, so therefore that means I can actually make this marking here. So it seems that we have angle A is congruent to angle E. We would have line segment CB congruent to line segment DB. And it seems like we have that angle B is congruent to angle B. Also remember, it may be easier sometimes to use 3 letters instead when naming these angles. So I would name it angle CBA, and that would be angle DBE. It probably makes it a little bit less confusing when you name it like that. So in saying that, we have an angle and a side. Now, the key here is where's the side located? Is it included or non-included? Hopefully you see that it's not in between my two angles, so therefore it is non-included. So this is an angle side. All right, decide whether enough information is given to prove that the triangles are in fact congruent. If so, state the theorem. Okay, so first one, A. Is triangle EFG congruent to triangle HDG? Yes or no, and then what theorem? All right, so I noticed that they have 2 pieces of information right now that are congruent. Seems that angle, I'm going to just put angle E since that's my right triangle, or right angle is congruent to angle H. Okay, and then they do show a side, DG seems to be congruent to FG. All right, so the thing is we're missing at least one more piece of information. So the question is, can we create it? Well, hey, what do you know? Right here, we hopefully recall that we do have vertical angles. So we can actually state that angle FGE is congruent to angle DGH. So now the question is, does it fall with one of our rules? Side, side, side? Definitely not. Side, angle, side? Nope. All right, so it's either hypotenuse, leg. No, not hypotenuse, leg, because I don't have a leg marked. Or is it angle, side, angle, or angle, angle, side? So key here is, where is this side located? I see that it's not in between my two angles, so therefore this would be a yes because of angle, angle, side. All right, let's look at B. Is triangle PQM congruent to triangle RQM? Yes or no? So they've given us that the 2 sides that are congruent are PQ is congruent to RQ, All right, they don't give us any angles at all, and we cannot make any assumptions either. So even though this may look like QM is perpendicular to PR, we cannot make that assumption because they're not marking it for us. The only additional mark that we can make is here on QM, because both triangles share side QM. So we know that QM is going to be congruent to QM because of the reflexive property. But that's it. I don't see vertical angles or anything else. So therefore, this is a no. We don't have enough information to justify whether this is whether these two triangles are actually congruent or not, because we need at least another side to be marked, or an angle being marked, or even a right angle being marked. But we don't have that, so therefore it is a no. Not enough information is given. All right, now let's look at option C. Number C, letter C, triangle LMP. All right, and triangle NMP. Are they congruent is the question. Yes or no? What theorem? All right, well, I see that we have these. Now, you may think that these are marked funny, but the reason why they mark it like that is so that we see that these two angles, they're still marked the same way. They're both using two curves. So they're telling us that this angle LPM is actually congruent to angle NPM, okay? But if they had matched the lines, it would look really super confusing. So that's why they do it this way. So I clearly see that we have two angles that are congruent. So the question is, can we mark anything else congruent? Hopefully you do see that both these triangles share MP, line segment MP. So we have established that angle LMP is congruent to angle NMP. Okay, so that's the top angle. And then we also have we have a side. We just figured that out, that MP is congruent to MP because of the reflexive property there. Both triangles share the exact same side. And then the last angle we have is angle LPM being congruent to angle NPM. So I know it's not a side or side angle side. So because we have two angles here. So key here is, where's that side located? Hopefully you see that the side is located in between our two angles. So if it's included side, then that means our answer is yes, it is a triangle, or you do have a triangle congruency. And the reason why is because it is angle, side, angle. All right, let's look at D. It says here that we're looking to see if triangle WXY is congruent to triangle YZW. All right, so let's see if we can mark a few things. Now, these symbols do not represent congruency. Hopefully, I hear you guys saying that these symbols represent parallel lines. So, there's a reason why they're telling us these lines are parallel. Okay, think about it like this. Let me say I extend these lines, these are parallel lines, right? And guess what this line right here would be considered? Yes, I know you know. That is a transversal. So that means we have alternate interior angles that we're looking at. Because notice everything's located inside the parallel lines. So all we have are interior. And then we also do have consecutive interior. That doesn't really help us in this case because we're looking for congruency. So the only thing that really helps us is remembering the rules of alternate interior. Okay, so I'm going to take away my picture now. So that should help us in establishing which angles are congruent. So we would hopefully, if you recall that picture, we would see that angle 3 is going to be congruent to angle 1. And we would also have angle 4 be congruent to angle 2? So the question is, do we have a side that they have the same or another angle? Well, the only thing we can establish for sure is we do see that they have this side in common. So WY is congruent to WY. So because, and now remember where our angles are located. We have angle, angle, and a side. The key is, where is the side located? The side seems to be located in between the two angles, so therefore it is included. So yes, these are congruent triangles because of angle, side, angle. All right, just a few more. State if the two triangles are congruent, and if they are, state how you know. I am going to do 2 of these with you and then let you do the other 2. All right, so let's look at this first picture here. So we see that they have sides marked, 2 sides marked, but, well, don't really give us anything else. And we have no rules, it's just a side. The only rule that's like that is the right triangle, but you have to have the hypotenuse marked and a leg marked, but you got to have a right angle shown. So this one is a no. All right, and I will do one more with you, and it is here. And let's see what we got. We have a side in common, and we do have an angle in common. So the question is, can you find anything else? Well, hopefully you do recall vertical favorite angles, vertical angles. So we do have 2 angles and a side. Now be cautious here. Where is the side located is the key. That side that we have identified as being congruent is not in between my 2 angles. So therefore, this is angle, angle, side. I want you guys to do number 3 and number 4 here. Okay. And then you have one more on your own. And I'm just giving you kind of a hint here. You can refer to all 4. So I'm telling you right now that it's not going to be an HL. Okay. Make sure you guys do not forget about HL. Sometimes it gets left out and forgotten about. Okay. But don't forget about that one. But for this one, you are going to refer to side, 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 angle, or angle, angle, side. Okay. And you're going to figure out which postulate, which one of those would actually work to make these 2 triangles congruent. Adios.